of the ellipse. So as we know, this is the are you able to hear me clearly?
Yes.
Yes, sir.
Yes, sir.
Okay, some I think check your internet connection. Somebody is saying voice is crackling.
Yes, sir.
Sir,
Now
now it's okay, sir.
Shall I continue?
Yes, sir.
Yes, sir.
Now, basically, we'll have some small idea regarding the ellipse here. So, what is a ellipse? I think it's a special case of a circle only. This is called like semi-major axis, semi-minor axis. This distance usually PB. This will call A. It will have two foci. Foci 1, foci 2. If it is only one, we'll call focus. If there are two focus, we'll call it as foci. F1, F2 are called as a foci here, that one. Okay, there's a one basic small condition, that one. So this is called like A is called as semi-major axis. Okay, agree, no? So there's a one condition. Then so what about the some relationship there? So if this is the distance R1 I call, okay, let me give another diagram. Let me choose one of the foci. It will be easier. So this distance from the near point, we'll call it, and let this distance be R2. Okay, fine. No? So let this be the AE. Let this be E, where E is called as eccentricity. Where E is called as eccentricity. So it is a distance from the midpoint. This distance will become AE, that one. So what is E? E is the eccentricity. The value of this, now if I go for geometry, it will be AE square plus B square. Or you can write expression for B or A, whatever that one, or the eccentricity will be in terms of by A. All you are going to learn in mathematics, just I'm making you to, because these things is what I'll be using, that one. Now,
Sir,
yeah,
sir, you told A is semi-major axis, right?
yeah. No, the further distance will be taken like this, A semi-major axis, that one. Okay, now after this, so what is R1? R1, can I write it as A minus AE? What is R2? Will be A plus AE. So these are the things what we'll get it. Okay, we'll get R1 and R2 like this here. So what are R1? R1, this is called like a near point. Near point, farther point. All this are their mathematics, because I'll be using here and there. So therefore, I'm just creating background here. Okay, after this, still somebody there. I'm switching off the video. Somebody by accident will turn on, no, and that's switching off video so that it will disturb everyone. Huh? Okay, don't take it in another way because anybody turning on their video, I'm switching off it. Huh? Just only not to have disturbance in the class. Huh? Fine. No, this is called as eccentricity. The near point and the farther point are given by this particular equation, or a into 1 minus c, a into this one. What is this eccentricity? So what is the significance of that? Is what and sir, what are the values of it? What values it can take? If e equal to 0, if e equal to 0, r1 equal to e and r2 equal to e, then how that it become a circle? Okay, clear this one. So as I further increase, so it will be like this. Huh? This is for e equal to some rough value equal to 0 point. Still it's an ellipse. Then if I make e equal to 0.99, and for equal to 1, it will be straight line. I will be discussing some problems like this, some application problems. So let's have a background. So the value of E matters a lot here. The value of E will determine what is that actually the shape of that ellipse. Hmm? So therefore now, what is this ellipse? Shall I say it's a uh, special case of circle only, to be frank. So this is a circle, e equal to 0, e equal to 1 will become straight line, and the value of e between 0 and 1, the ellipse is going to have different shape. So when we are discussing some problems, no, sometimes we'll get ellipse like this. Hmm. So sometimes we get an ellipse of like this here. So any reason for that? It all depends on value of e. So how do I come to know? The situation will be given in the problem in such a way that you can assume that suitable shape. So you are going to learn in detail in mathematics. So don't bother again anything about learning ellipse in detail. So who don't know ellipse, this is enough. What do you mean by semi-major axis, semi-minor axis? What is the near point, farther point? What is this F? F will call it as focus. And F1 and F2 are called as foci. These are some just basics of ellipse. And equation of ellipse, I think everyone you know it. X square plus a square plus y square plus b square is equal to 1. So there's the equation everyone knows. So I'll keep that one. Since if a equal to b, then it becomes circle. I think equation of ellipse. If a equal to b, then it will become x square plus y square equal to a square. That will become equation of circle. Even I feel if you don't know this particular all mathematics also you can manage because we are bothered about our laws, conservation of Anglo term, conservation of mechanical engineering. Some numericals, if you go for Olympiad somewhere, no, they are asking based on this also. So you should be a little bit careful. Okay, let's get into this one. So now we are discussing the planetary motion. So for the planetary motion, so Kepler's law of Kepler's law of planetary motion. Now he suggested that all planets revolve around Sun in elliptical orbit with Sun at one of the foci. With Sun at So now there's a law he has proposed. This is nothing but called as law of orbits here. Now, what are the orbits here now? So what is the condition? If the energy of the system, if it is negative, no, then the planets are going to revolve in a closed orbit. So regarding this one, just telling if the total energy of a planet is negative, then then the orbits will be closed. Closed means what are the closed orbits? Example, closed orbits are what? Like what are closed orbits? Closed orbits are circle and elliptical. These are called as a closed orbits. Next again is putting one more condition. If energy of a planet is greater than 0, the orbits will be open. What do you mean by open? Open orbits is telling. What are open orbits? Parabola, like a parabola, hyperbola. These are not like, so you look at some comets, no? They will not describe periodic motion. So those particular, if you go and check the energy of that particular comet, so what it will be like a greater than 0. Then in that case, what happens? The orbits will be parabola or hyperbola. So this about the first law of orbits is what it's telling. So what we have to check it like, when you calculate the energy of planet, is it positive or negative, or energy of any revolving body about any some other thing. So check particular energy. If it is less than 0, it's like closed orbit. It can be circle or ellipse, and the eccentricity of that, the value of E or the eccentricity will determine how the shape of the ellipse. Already we have just seen that for different values of E. Clear this one? Then now what will happen if the energy of a planet, if it is greater than or equal to 0, greater than or equal to 0. I'll put condition. So here, if greater than or equal to 0, then it will be open orbits. What are open orbits? Parabola. These are not like a periodic motion. Periodic motion will not describe. The planet will not describe periodic motion. Here what will happen? The planet describe periodic motion. Motion of planet will not be periodic. Okay, this much is what he is telling next year. There's the first law. Okay, fine. So this about is saying more about what, like type of orbits, everything, that one. So now we'll go for the second law. First law is called a law of orbits. Regarding based on the energy, what happened is classifying the type of orbits here.